Here we're going to look at question 20 from the NSAA 2018 paper. In this question, we're given a circuit which has a battery, an ammeter and 3 resistors of resistance 12 ohms, 15 ohms and 3 ohms respectively. We're also told that the current through the ammeter is 0.2 amps. Since we're not told what the voltage produced by our battery is, I'm going to go ahead and label it as V. Now, I'll do this because with circuits such as these, we have resistors in series, a current, and a battery. There's not much we can do beyond Ohm's law, as you'll see in a moment. Now, Ohm's law requires a voltage, a current, and a resistance. So, it would make sense to go ahead and label our voltage now. The question then tells us that the battery is disconnected and resistor 3 is removed from the circuit. The battery is then put back into the circuit, giving us a brand new circuit. This is going to look like this. And since the battery that we put back into the circuit was the same one as the one that we began with, we know that the voltage produced by it is also going to be V. Now, with this circuit, since the voltage is the same and the resistances are different, we can't be sure that the current is going to be the same. So what I'm going to do is go ahead and label this current I, since we don't know what it's going to be, and there's a good chance we're probably going to have to use it. Then, reading the final part of the question, what do you know? It asks us, what is the new current in the circuit? That is, the value I that we've just written on our circuit diagram for the current in the circuit once the resistor R3 has been removed. Since we need to try and find the current I in the second circuit, we should try and find an expression for this value. The easiest thing to do is probably to go ahead and use Ohm's law on this second circuit. The reason being that it would include our current I, the voltage of the battery V, and the total resistance of the circuit, which I've labelled here as R12. So, to find our current, we need to find the voltage of the battery V and R12. Let's go ahead and try and find the value of voltage first. So the only way of doing this really is to go ahead and look at our first circuit. We can use Ohm's law on this first circuit. Now, the reason we do this is that we have a value of the current, 0.2 amps, and we also have the resistance of each of the individual resistors making up the circuit. So if we were to go ahead and use Ohm's law, we'd get an expression like this, that the voltage in the battery is equal to the current through the circuit, 0.2 amps, multiplied by the resistance of the circuit, R123. Now, to try and find the resistance of the circuit, we can simply add the resistances of each of the resistors. And this is because the resistors are in series, which makes it nice and easy. So we can just add together 12 ohms, 15 ohms, and 3 ohms, giving us a total resistance of 30 ohms. Therefore, the voltage through the circuit, or the voltage of the battery, is going to be 0.2 amps multiplied by 30 ohms, giving a value of 6 volts. Since the battery is taken out and then put back into the circuit once resistor R3 has been removed, we can go ahead and presume that this voltage should be the same in both cases, since the battery has not been affected at all, so its voltage will remain the same. Now, let's go ahead and look at the resistance of the second circuit, R12. Now, since this circuit is just made up of the two resistors together in series, we can go ahead and do just as we did previously and add together the two resistances, R1 and R2, giving us a final answer of 27 ohms. So, if we substitute our value of 6 volts and 27 ohms back into our original equation, then we go ahead and find that the current is equal to 6 over 27, which simplifies to 2 over 9. Now that we have our answer that the current is equal to 2 over 9, we can go ahead and look at the answers which were given in the question paper. Obviously, these are all decimals, so we're going to have to convert our current into a decimal. If you can't do this straight away, then the best thing to do is probably to have a go at process of elimination. So, for example, we could go ahead and look at answers F and G. Now, we know that 2 over 9 is less than 1, so therefore it cannot be F or G since they're both greater than 1. Also, it should be fairly obvious that the answer is not 0.5, since 2 is not 1/2 of 9. Next, we know that 3 over 9 is a third, which is approximately 0.33. Therefore, 2 over 9 has to be less than 0.33. So it cannot be that answer, and it also, therefore, cannot be D. Next, we can consider answers A and B. We know that answer A, 0.2, is equal to 2 over 10. 2 over 10 is less than 2 over 9, and therefore it must be greater than 0.2, leaving the only answer being B. So our final answer is B.